Hello, math students. This is Module 2, and it is called Rational Numbers. And the lesson is Lesson 2, and it is called Adding Integers and Other Rational Numbers. Okay? And so basically, this is going to build upon what we learned about our types of numbers, remembering that integers are rational numbers that represent the positive and the negative whole numbers in our number system. So the goal that we're doing in this lesson is today we are going to learn how to add integers and other rational numbers with different tools. The question that I want you to be thinking about in this lesson is, what are the rules for adding integers? Some things to know. A couple of tools for adding rational numbers are the number line and an equation. The number line comes with the number line itself and the use of arrows. The arrows on the number line tell the length, so how long it is, the direction, and the sum, because we're adding. So the sum means the answer to an addition problem. So the length is determined by how many units the arrow spans. So if your arrow goes 5 different spaces, then you would know that the length is 5. The direction tells you whether the integer is positive if the arrow is going to the right, or negative if the arrow goes to the left. And then the sum of the arrows tells you the final position. Now some of you are going, okay, Mrs. Nelson, I don't understand. Well, I'm going to show you right now. So we're going to try it with this example, and it says show 4 added to -7. So our job, first of all, is to find -7 because it says show 4 added to -7. So one thing that you have to know that whenever you're using a number line to help you is you always start at 0 to find where you start. So if it says show 4 added to -7, -7 is the amount that we begin with. So we start at 0, okay? And the way I start at 0 is I put a dot above 0, and then I have to take my arrow all the way to -7. So I'm going to go to the left all the way to -7 because that is where I begin, okay, because it says show 4 added to -7. So I had to get to -7 before I can add something to it. So now I'm sitting at -7. My arrow is 1, 2, 3, 4, 5, 6, 7. So the length is 7. The direction is to the left, so that means that it's a -7. And now I'm adding 4 to it. So I'm going to start right at -7 where I have, and I'm going to add 4 to it. So that means that I have to go to the right because adding means you're increasing. So I'm going to go 1, 2, 3, 4. And I end up right here. And so the answer, or the sum that I ended up with, was -3. Okay? So the answer to this algorithm, -7 plus 4, gives me an answer of -3. Because I went to the left 7 spaces, then I added 4 positives to it, so 1, 2, 3, 4, and I end up at -3. So that's how you use the number line to help you adding integers, okay? So then the next thing that we talked about above was using equations using verbal descriptions. Math written in words instead of symbols can be tricky, okay? The thing to keep in mind, sorry, I have to turn the page. The thing to keep in mind is the use of equations makes it a lot easier. So it says the sum of -8 and 6 is what number, okay? So important words right here is this word sum, so that means we're adding something. -8 tells you the integer that you're looking at. The word and reminds you that you're adding, and the word 6 tells us the integer that we're looking for is what number. So you're looking for an answer, okay? So it says, first of all, circle the important words. So I actually put squares. Sorry, I'll circle them. So here's an important word. Here's an important word. Here is an important word, okay? And then it says set up a blank equation. So here's my blank equation. The reason why I put plus is because it said sum. And the reason why I put an equal sign is because it says is what number. Is kind of an important word, right? And then what number is what we're looking for, so that's important too. And then it says fill in the given values. So the sum right here of -8, so -8 goes here, and 6 goes here, and then we're supposed to solve. Okay, well, I can do that pretty easily because I just learned how to do that on a number line, right? So I always start at 0, and I have to go 1, 2, 3, 4, 5, 6, 7, 8, down to -8 because that's what I started with. So I'm going to go to -8, and then it says add 6 positives. So I'm going to start at where I have 1, 2, 3, 4, 5, 6. Oops. 1, 2, 3, 4, 5, 6. So this is where I'm going to end up, is right here. So I'm going to add 1, 2, 3, 4, 5, 6. So that's where I ended up. And if you fill in your number line, you end up with, taking a look at it, sorry, I ended up with -2. So my answer would be -2. Okay, so that's how we use the equation to set it up. Now it says, now check with the chip method. Well, I don't know if you guys are familiar with the chip method because I don't know if you learned it in 6th grade, but the chip method is the use of these chips that we have that are called positive and negative chips. And so basically they're just circles with either a positive or a negative symbol on them. Okay, and so for this exact example, you're going to build with chips what you have. So this one says that I have 8 negative chips. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. 8 negative chips. So I'm going to put negatives in there. Sorry. Put those in there. So that's what it says that I started with. I have 8 negative chips. Then it says that I'm supposed to add 6 positives. So there's 1, there's 2, there's 3, 4, 5, 6. So there's my 6 positives. And something that you need to know, hold on, something's wrong. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Oop, I drew an extra one, so let me squish that one out. Sorry. Okay, so now it says that, or what you need to know about the chip model, just like batteries, is that when you have a positive and negative, if you put them together, they cancel each other out. So that becomes a 0 pair. So that's a 0 pair, 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 that's a 0 pair. So what am I left with when I'm done? I'm left with 2 negatives. And so that's how I was able to choose or use the chip model to help me figure it out. Because what you have to remember, a positive combined with a negative makes a 0 pair. And what a 0 pair really is it has a value of the number 0. 0, 0, 0, 0, and 0. So 0 plus 0 plus 0 plus 0 plus 0 plus 0 is 0, plus 2 negatives would give me a -2. Okay, and so that's the chip model that you can use to check your answers. All right. Okay, so now let's keep going because it says rules for adding rational numbers with the same sign. When you're adding a positive and a positive, you get a positive, and that makes sense. If you have all positive numbers, so you take a positive, right, plus a positive, you have no other choice but to end up with an answer that is positive. Okay? When adding a negative and a negative, you get a negative. And that's very, very true because, look, if this is all negatives and this is all negatives, what is my answer going to be? You have no other option to have it be anything else because all you have is negatives here and all you have is negatives here. So the only thing that you could possibly have is more negatives. Just like all you had is positives here, all you had positives here, all you can end up with is more positives. So when adding a positive and a positive, you get a positive. When adding a negative and a negative, you get a negative. It makes sense, okay? Then we're going to throw something in that could get a little bit tricky if you're not paying attention. So I need you to pay attention. Rules for adding rational numbers with different signs. Okay, with different signs, when adding a positive and a negative, you take the sign of the number with the greatest absolute value. And what this means, kiddos, is just use your chips, because you're going to be able to see if you use your chips. So according to this little sentence, I have 3 positive chips. So positive, positive, positive. And then I have 11 negative chips. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And these are all negatives. Well, we just learned from up above that positives and negatives, when they combine, they make zeros. So there's a 0, there's a 0, and there's a 0. So what are we left with? 8 negatives. So if you look over here and you use this, when adding a positive and negative, you take the sign of the number with the greatest absolute value. Well, how far away from 0 is 3? 3. How far away from 0 is negative 11? 11 hops. So which one has the bigger amount, 3 or 11? 11. What is the sign of 11? Negative. So our answer is negative 8. Okay? And so you can also check it using your chip model. Either way works. All right? And it's very important that you remember these. Okay? So hopefully it's starting to make sense. The other thing that we can do is we can check it on a number line, and that's figuring out the distances. So remember that if you take a positive 3, you always start at 0. So we're finding the distance from 0. So we're starting at 3, right? And then it says we're adding 11 negatives. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I end up right here. And what is my answer? Negative 8. So 3 plus a negative 11 equals negative 8. So we just saw it in 2 different ways. You saw it on the number line, you saw it with the chip model, and then you also remember that when adding a positive and a negative, you take the sign of the number of the greatest absolute value. Okay? All right, so let's go back to our goal so that I can make sure that I gave you a lot of information in this lesson. Today we are going to learn how to add integers and other rational numbers with different tools. So we learned the number line, we learned the chip model, and we learned understanding how to write it as an equation, which is very, very helpful. All right, kiddos, that's all I have for you in this lesson. Talk to you soon. Bye.